So the light meter is reading less than 1 lux at 0.8 lux. It's quite dark in here. There is some light coming from behind me. If I turn that off, this goes down to like 0.04 lux, and it's almost dark then. I can just barely read the display. But at 0.8 lux, it's going to be a small fraction of the light when I turn the light on. So the light meter is facing down, trying to get the reflection off the solar cell. So if I turn this lamp on, which is just LED white light, we can see that the lux reading goes up to 1250. So there's quite a bit of light reflecting off everything here. It's not all being absorbed. Even though I've got as much black fabric around as I can get, there's still lots of light being reflected, and it sort of, I'm going to try and cover up the solar cell just to see if I can tell that there's more light being reflected off the solar cell than off this black cloth. And it went down to 113 lux. So if I take the black cover off, I get 1191, depending on how much I cover up here. So I get about 1200 lux reflecting off the solar cell, which means it's not absorbing 100% of the light. Now, this isn't, a very accurate measurement of how much light is being reflected versus how much is being absorbed, but it does indicate that there is some being reflected, so it's not 100% collecting all of the light. So the efficiency is, of course, not just about how much light is being converted to electrical, but how much light is actually being absorbed at all. Some of it's being reflected, and that's not being used to generate electricity. Now, of course, some of the light is being reflected off the surrounding border, which is white, of the solar cell. So it's not a really accurate measurement here of how much is reflecting off the solar cell itself. But needless to say, some is reflecting off the solar cell, and if we take this away, the camera shows that this isn't black. It's actually looking a little bluish, which means that there is some light being reflected off the surface of the solar cell, and even this black cloth is reflecting some light, according to this camera. To my eye, the black cloth looks black, and the solar cell looks a little bluish, but it's not quite as brightly blue as it shows up in the camera here. Okay, now I've turned on my movie lights and turned off this LED direct shining light. And you can see not so much light is reflecting off this thing, because the lights are coming from this direction, and they're bouncing in that direction, so they're not reflecting back this way very much. So that does look fairly dark, even to the eye. But if I turn on this light, you can see that it does start to reflect some of that direct light. And this meter is showing the voltage on the capacitor when I connect it, but this one is going to always show the output voltage from the regulator. So if I could monitor this, the meter on the right is showing the voltage on on the capacitor, which has just crossed 3.9, which is when this one turns on. So with the movie lights on, it's enough to keep that capacitor charged up pretty good. I'm going to turn one of them off. I should be taking readings with my light meter here. So the light meter is reading 334 lux. And that seems to be enough to keep this thing running the output. And I don't know if we can see the LED here. The LED is not on. Okay, so that's why it's working. If I turn the LED on, which is just connecting this resistor, you can see maybe that the LED turned on here. Yeah, so that's the LED. I need a little black background for that. Just hang on a sec. Okay, I put a little piece of foam there. Not very black, but it's good enough so that we can see the LED, which is now running and discharging. So we can see the voltage on the capacitors going down, but the regulator is still hanging in there at 3.3 volts. And the LED is still running. I know my hand's in the way, but as long as that 3.3 volts is there, the LED is going to be drawing current. And I'll probably cut out some of this video to make this go a little quicker. But I think this is going to eventually get down low enough that the regulator will turn off. So you can see the regulator voltage is going up a little bit. As this voltage drops, it's trying hard to keep the voltage up. So now this voltage on the capacitor is below 3.4. And as it gets below 3.3, this one's going to have a problem. So now the capacitor voltage is 3.2 and the output voltage is sort of tracking that. It's going down at the same sort of rate as the capacitor. And at some point it will actually cut off. It will save the whole thing from powering something that needs a higher voltage. There it goes. So at 3.13 volts on the capacitor, the output turned off. And that stopped the discharge on the capacitor, because there's still some light here. It's still trying to charge this up. It's just only 300 lux. You can see it there. Depending on whether I'm blocking the light, because it's coming coming from over my shoulder here, so I can sort of block it, and that reading will fluctuate a lot. Okay, so let's just watch it charge up one more time. I'm going to turn on all the lights, and we'll watch that thing charge up. So this meter is reading 800 lux, and of course if I put it where the solar cell is, it's reading 1470, somewhere around 1500 lux. So now that we've got the solar cell in there, so it's not right in the direct light here, so it's only 1100 lux. But the actual solar cell is probably seeing 1400, and you can see the capacitor voltage is going up. It's at 3.2, 3.3 now, and the output will turn on when it hits 3.9. And I don't know, you can see the LED here is off. So it's up to 3.4, and I may cut out some of this because it's taking a while to get there. So this gives you a pretty good feel for how fast the capacitor charges up when there's no load right now. The output is turned off with about 1500 lux, which is a fairly bright light. This LED is, I don't know what that thing puts out, probably around 300 lumens. It's not a terribly bright light. I have much brighter LED lights, but it's in a nice little lamp. So we're up to 3.7 volts on the capacitor, and when it hits 3.9, we should see this guy suddenly pop up to 3.3 volts. So we're at 3.8 on the capacitor, approaching 3.9. So here we are, 3.9, and it should turn on pretty shortly after that. I've done this a few times, and the voltage varies a little bit. There it goes, 3.93 roughly, where it turned on. And we can see the LED is running. I don't know if we can see that really, but it is running. It's perfectly visible to my eye. And the capacitor voltage is continuing to increase, although this meter has turned into a scale which has got fewer decimal places. And I'm going to see just turning everything off. We'll try and discharge it again. Down to one light. The movie lights are huge fluorescent lights in big diffuser reflector type shrouds. So there we go at 3.6 volts. This guy gets an extra digit of precision, so you can actually see it discharging much better. Okay, that's starting to look repetitive, but I've done it a number of times, and it's pretty similar each time in terms of what voltage it turns off at and what voltage it turns on at. The load is really not anything magic. It's just a 1K resistor in series with an orange LED. The orange LED, I believe, let's just take a quick look at that, has 1.7 volts across it, 1.74 volts. So we can calculate the current through that LED by subtracting that voltage from the 3.3 that we see over here, and dividing that voltage difference by this 1K resistance. But that's just an example load. I've charged it up and it's outputting 3.3 volts here, but I've taken the LED off. And we can see, and I've also covered the solar cell so that it's not really charging. And we can see the voltage on the capacitor isn't really changing. So it's maintaining 3.3 volts without really discharging the capacitor. So that regulator must be taking some current, but it's not really discharging it too fast. So whatever it's doing is pretty efficient. So it's pretty efficient at storing charge, no question about that. I don't know how many hours this thing would last, but it'll take a long time to find out.